Okay. Okay, so in this video we will learn about hemophilia. Is focus problem. We will learn about hemophilia. So the thing is this. Now hemophilia is also known as royal disease. It's also known as royal disease. Okay, or bleeder's disease. Bleeder's disease. Now, why is it called royal disease? Previously, it was found in the family members of the nothing special reason. Family members of it was found in the family members of royal family. Family members of the royal family. There is a story to it. I will discuss that. Okay, but why it is called bleeder's disease is the reason because when hemophilia occurs, the blood clotting mechanism becomes weak, and when the blood clotting mechanism becomes weak, so there will be higher flow of blood from wounds. So that's why it is called as bleeder's disease. Now there can be two types of hemophilia, hemophilia A and hemophilia B. So now in hemophilia A and hemophilia B, what happens is in hemophilia A there is no formation of factor or clotting factor 8, and in hemophilia B non-formation of clotting factor or factor 9. So these are the two types of hemophilias that exist, and because of both of them, blood clotting becomes weak and the bleeds. So that is what is called bleeder's disease. Why royal disease? Reason. Now question is why on family members of the royal family would only have it? That answer you will have when I will say how you can inheritance. Okay. So when I'm going to tell you how you're gonna track this inheritance. Let us try to see. Okay. Suppose in pedigree form, if I express, before that, you should know another thing about hemophilia is that it is a sex-linked inheritance or sex-linked disease. Now, when it is sex-linked disease, the disease gene is either present in the X chromosome or in the Y chromosome. If it is present in the Y chromosome, it will be mentioned that it is a Y-linked disease. And when we normally say, we try to say that it is X-linked disease. X-linked disease means the mutation or the disease or the problem lies in the X chromosome or the X sex chromosome. That will not be, or that's correct form or alternative form. For example, generally when you write alleles, how you do? A. So if here one it is non-lethal. If it is dominant, there is no problem. You have learned this in sickle cell anemia. But then it happens because it's in these two chromosomes, it's a homologous chromosome. Its sequence is present also. Both are sequence of the same. Both are sequence of the same. Both carry sequence for the same character in both the. So these are homologous. But Y chromosome contains homologous to X, it has something else. If the of suppose XY, if the male is a carrier, definitely to carry in the X chromosome, call it affected. Okay, an affected male. Okay, or a carrier male. But if we talk about carrier female, then how the carrier female will be? The carrier female will be, it in one of it. But if this locus is a problem for which is schizophrenia, there is a correct locus present here. If some factors 9 and 8 would, but it is not similar. So how is a carrier female, and if it is like came like this, if it is like this, then it is a female. This female is not alive. This female is alive. So this is, and an affected female will be like. Let us do a pedigree. Suppose this is a male, normal male, and I represent it in this way. I call it an sex chromosome carrier male. Okay, this carrying one of the chromosomes. He will, in the previous you have drawn the affected one like this, and here you have this. So what is the difference in this two? Here is a carrier and is an effect, and the problem is in autosome. But here it is a carrier, and it may not have the disease, and it is carrying in chromosome. This is the difference. If we go, suppose they have two children, both of them are normal and a boy. So he must be XY and be later be like. Now, as because it is a boy, he will receive Y. Now, he can receive this also, or he could receive this also. And as because this is a girl, she would receive the normal X from the father, and this X would have also come, or normal X could have come. Two may be. This would be the normal one, this would be the diseased one, this would be the normal one, and this would be, so this would be the diseased one, and this would be the normal. What basically happens is that we seeing the pedigree, we can see that it is not. So it is, this should be the genetic constitution of this, and here this should be the genetic constitution of this. If again they would have drawn like this, or if they would have a like this, okay, so like this, then I would say she is also X bar. Okay, because she will receive the X from the father and this. Now there could be various questions regarding this pedigree analysis kind of things. Now, if in place of this father is carrier and man is a carrier female, then let us draw the Punnett square, and we find that it will be both be carrying this. Here it would be carrying X, Y, X bar, and 1. This would be a normal male. Right? This would be a diseased male. Right? This would be a diseased female. It would be a diseased female. Okay, diseased female. So that in your questions given that how many percent of the males, okay, or in a cross would be affected, then it is 50%, because males, these two are males, 50% of the males. So it would be affected, 75% of the childs will be affected. How many females will be affected? 100% of the females will be affected.